Welcome to the Wheats on Your Mind podcast. My name is Aaron Harries. Wheats on Your Mind is brought to you by the Kansas Wheat Commission and Kansas Association of Wheat Growers. It's always fun to talk about the weather, and I'm pleased to have Ross Jansen joining us on this episode. Ross is the chief meteorologist at KWCH-TV in Wichita. Ross attended college at the University of Kansas and received a Bachelor of Science degree in atmospheric science. His broadcast career started at 19 years of age at Channel 6 in Lawrence, where he had the opportunity to work both as the morning meteorologist and as chief for about 2 years. Ross has done some fill-in work at WIBW in Topeka and then moved to Wichita in 2004 to work at KWCH. And welcome, Ross.
Nice to be on the show today.
So you are a farm kid also, grew up on the family farm and ranch near Geneseo. Much like myself, you probably occasionally return to the farm to provide free labor, I would suppose. But so tell us a little bit about your background in agriculture and weather.
Yeah, so I was one of those that got interested in weather at a really young age. Fourth grade is probably my earliest memory of being fascinated by weather, the changes. I thought it was always fascinating, too, how somebody could tell you that in 5 days, a storm was coming. It often made me think, how do they know that? I mean, what are they looking at, and how do they get so close? Of course, the accuracy from 30, 40 years ago, it's different nowadays. I mean, we can look 7 and 10 days out, and we're even getting 30 and 60-day trends that are at least close most of the time. But just, I think probably, to sum it all up, I was always amazed at how no matter what you did, everybody talked about the weather. So whether you've got a job in town or your life is made on the farm, you've got your livelihood in agriculture, the weather is just so much of a factor in everything we do. And so with the changes, how it affects everybody, that's really what sparked my interest, and it just continued on from there.
So I know your family is in the cattle business. Did you have row crops and wheat also on your farm?
Yep, we did. Couldn't tell you exactly how many acres, but we were fortunate to have a little bit of variety of all things agriculture, from wheat, milo. We've never really been that big in the corn business because just, dryland corn 10, 15 years ago would always be a struggle, and you just had to have the perfect summer in order to make it profitable. So we never really did that much corn. I know there are a lot of different varieties out there now that can withstand the heat and some drier periods. But we did have row crops. We also put up a lot of hay. That was primarily my summer job, was to help with the swathing and the baling and stacking hay bales. And then, we were also heavily involved in cattle and 4-H and just basically all things ag. I would venture to say, we had a couple hundred head of cattle, and it was always fascinating. Different times of the year you're busy with cattle, and in summertime when it's hot and dry and the cattle are out to pasture, we were busy putting up hay. So never a downtime really on the farm.
You no doubt, as most of us, have seen the evolution of agriculture. As you mentioned, the changing technology and seed and genetics has kind of overcome some of the weather obstacles that we've seen in the state of Kansas. But in regards to wheat, we try to kill wheat many ways in Kansas, and you're familiar with most of them that we throw at it every year. And it seems like weather has won that battle in the last 2 years, unfortunately, with this severe drought. So let's get into the recent La Nina and the drought effects on wheat production. We know we can grow wheat with very little water, but to have a situation where we've seen so little rainfall and a crop failure like we had this past season says a lot about the weather pattern, doesn't it? How big and effective was this last La Nina?
Well, I think in going back and doing some research about this, the drought really started to develop in late 21 and then was just solid all the way through 22 in most of western Kansas anyway. And then we started to see it spread further east. It developed last summer, continued across much of central and eastern Kansas then as late summer and fall continued on. And I think, La Nina by itself tends to favor warm, dry periods. I think the biggest influence from La Nina is felt in summer and early fall. And the fact that it was a moderate to stronger La Nina, and then it basically continued for 3 years in a row. When you start to have ocean temperatures that are that steady, and let me just remind you that La Nina is a colder than water setup that we see out in the Pacific. Because it lasted for so long, again, La Nina by itself tends to favor drought and drier and hotter summers. With it being so persistent, I think that's why we saw such expansive drought develop through much of the central U.S. There are a lot of areas that are still struggling against that, even as we speak.
How would you compare it to the drought of maybe the 50s or going back a little bit further in weather records, the length and severity of La Nina?
Sure. La Nina looked like in 55 and 56, because I had to pull some of this data too. It looked like it was a weak to moderate La Nina. So I think the strength of the one that we just had is comparable to what we had back in the 50s. Now, and just doing some more research, I found that 1951 and 52 was a very wet summer, and it was followed by a very wet winter. But then right after that, which was an El Nino setup, by the way, 51 and 52 was El Nino, so wet summer, wet winter. And then we quickly flipped over into La Nina going through the mid-50s, and we saw some pretty rough drought that developed in. So I would venture to say very comparable. So that's why, when we look back at that period of the 50s, there was also a period in the late 80s that was really dry and hot. I know my dad talks a lot about 89, 88, 89 being a very hot summer too, with significant drought. Those were all La Nina setups. So when somebody tells me we're going into a La Nina pattern and it's going to be, either moderate or strong through the summer season, it's not always textbook setup, but it does favor longer, hotter periods and the likelihood of drought. So I think from a planning standpoint, when thinking about the number of acres that you might be putting out, if we're transitioning toward a La Nina, I think one should be a little bit guarded about how ambitious you get, because it does favor dry stretches of weather.
Before we get into talking about the current pattern, it boggles the mind almost. Well, how we seem to end droughts in Kansas is by having excessive rain during wheat harvest. And how did we end a drought, erase a drought in western Kansas in literally 3 months? Started raining the end of May and just kept on raining.
Yeah, it was really, fascinating to see how this all evolved. But given the rapid decline of La Nina and the onset of El Nino, we figured that the summer would probably have something different for Kansas this year. And I think if anybody questions whether or not those ocean water temperatures and their influence on jet streams and overall patterns, that's all you need, because the La Nina was basically gone by May, and we were seeing the onset of El Nino. Now, we're not totally sure exactly how strong this El Nino is going to be, because it's going to continue through fall and winter. But given the rapid decline of La Nina and the rapid warming of the water out in the Pacific Ocean, we've seen just a dramatic shift in the overall pattern. And basically what has happened, we've had night after night, which is the key to breaking a drought. You've got to have not just one big rain followed by 2 weeks of nothing. You've got to have this repeated pattern of rain. And that's exactly what happened. We had the high pressure, the big ridge, which sometimes is referred to as the heat dome, but this upper high has been positioned over the desert southwest, and around that, on the edge of it, you get storms that form out there on the high plains of Colorado and Wyoming, Nebraska, and then it drifts down into western Kansas. So we saw night after night of that, almost to the point that, most of us were getting a little irritable because we weren't getting good quality sleep, because every night we'd have another round of storms. And that's how you break a drought, when you have day after day of that kind of pattern. Now, unfortunately, we haven't been able to bring some of that higher quality rainfall farther east. And so when you look at the overall drought picture, yes, we've got areas in western Kansas that basically went from D4, which is the highest level of drought, down to no drought at all. But we still are struggling against it across the eastern 2/3 of Kansas. So it's basically night after night of storms, and we're going to probably see that return here in a couple of weeks.
Yeah, it was amazing. That was just such a high plains focus, and every night that repeated the storms. But I've never seen in a year where we went from wheat being abandoned to drought to wheat being abandoned for weeds. And so, frankly, it's been quite the anomaly. Now we're, as you mentioned, transitioning into El Nino. And as I understand it, from a wheat farmer perspective, it means wetter October through March. And for an industry that has had very little moisture for fall planting time the last couple of years, seems to me that maybe holds a little bit more promise for wheat farmers.
Yes, I think so. Again, we're not totally sure about the strength of this oncoming El Nino. We're expecting that it's probably at least going to be a weak to moderate El Nino, which would have water temperatures about a degree or so above normal. Last check, it was zero point 0.8 degrees Celsius above average, which is just barely getting into the El Nino classification. But when we have this El Nino setup, we tend to see the southern half of the United States wetter than average. So thinking about how the summer has evolved, we've been hearing about the intense drought and the heat that's been in Texas and Oklahoma, parts of Louisiana too. Those areas are likely going to flip around and start to get better rainfall going into the fall and into the winter season. So if it were me, seeing the onset of El Nino, I just think that we're going to have a very different winter. And I also think that that's going to carry over through spring and probably early summer. So I think there's a little bit more confidence here that the rainfall is about to set in and we're going to see some very different conditions play out, with western Kansas just on the leading edge of this change that we're going to see. The rest of us, it's going to take a little while longer, but I'm expecting that, yes, going into fall, we will tend to see a little bit more rainfall. October is still kind of a wild card month, November too, but we feel like December and getting into the heart of winter, we're going to definitely see more precipitation because of the El Nino that's shaping up out there in the Pacific.
So in the transition between La Nina and El Nino, is it kind of just like throwing darts at a board here? There's so many other factors in play. Is that correct? There's other ocean oscillations and things, and I guess it's your job to figure out which ones to put the emphasis on.
Yeah, and that's where we struggle because when we make that transition from La Nina to El Nino, our computer modeling sometimes is a little bit off because it's trying to get a hold on just the strength of what the El Nino is going to be. But when you mention other oscillations, we study those too. And just to mention a couple of them, there's what's called the PDO, which is the Pacific Decadal Oscillation, and it's either positive or negative. And right now we're in a negative PDO where the water temperatures off the western part of the United States, off California and Oregon, that water tends to be a bit warmer than average. And so that can influence the pattern as well. And then there's something that's called the NAO, or the North Atlantic Oscillation, and we continue to be in a pattern where that has been basically fluctuating back and forth. But we think that the NAO likely going to be in the positive phase. So when it's positive, it tends to favor warmer temperatures across the country. When it's negative, there's more cool. So there are other oscillations that we do continue to keep a close watch on. In looking back, through the past years, because I'm trying to find some trends and, maybe where these oscillations line up with each other, it's a little bit more of a slam dunk in making a long range forecast. And what I have found that when we go into El Nino and when the PDO, or the Pacific Decadal Oscillation, is negative, we have wet summers and wet winters. Well, right now, the PDO is negative, and we've got an onset of El Nino. It's a little bit more of a wild card as to what's going to happen. But I think the El Nino still outpowers the PDO in this kind of situation. So even though one may say, well, the PDO might suggest we're going to continue with dry and more fluctuating temperatures, I think the El Nino itself is a stronger determining factor here that we will be in for wetter conditions going into the winter and into early spring. So there are other oscillations out there that we do study, and we've got to look for, when these sync up. So again, El Nino and negative PDOs, wet summer, wet winter, but right now, they're going to be kind of offset where we've got El Nino and we're dealing with a negative PDO. So kind of interesting how this stuff all sets up, but I would venture to say that given the fact that we've got an oncoming, in fact, already determined to be an El Nino, I like the way things are trending for us to have better chances of moisture this fall, but also our winter temperatures, just so you know, tend to be a bit milder. So we may not be as cold as previous winters have been.
PDO, I assume by decadal in that name, that it's a longer term oscillation?
It is. And when we go back and look at how it's fluctuated over the years, what I've determined is that it tends to be negative more than it's positive. And it's been negative now for trying to remember the graph that I saw just yesterday. I believe it's been negative now for 8 to 10 years. It's been quite a long stretch of a negative PDO. So we'll just have to kind of see how this plays out. But it's one that does not fluctuate nearly as often as the El Ninos and La Ninas, which tend to be about every 18 months to 24 months. We tend to flux in and out of one or the other. So it was kind of unusual to have 3 years consecutive of La Nina. Normally, they don't last that long. So going into El Nino, we feel like it will be with us for probably 12 to 18 months. And then we could go back to what's neutral. And we don't hear a lot about neutral phases, but they do exist, where the water temperatures are closer to average, and therefore we can't determine El Nino or La Nina. And in those scenarios, it's much more difficult to make longer range predictions because we don't have that extra influence, if you will, on what's going to be happening with the pattern. So if we're in El Nino or La Nina, we have a little bit more confidence about longer range stuff. When it's neutral, sometimes it's a bit more up in the air.
For the sake of someone of my level of scientific knowledge, just how important are ocean temperatures and overall weather, and how do those ocean temperatures truly affect the way the weather moves? Is it through trade winds, water temperatures? How does that all happen?
Yeah, when the water temperatures are warm or cool, it does impact the trade winds, but it also influences where thunderstorms out in the ocean begin to develop. So, for example, when we go into an El Nino, which is where we are right now, the area of thunderstorms out in the Pacific tends to be right where they're having a lot of active weather right now, which is just off the coast of Baja, California, west of Mexico. That area sees a tremendous amount of thunderstorms. But then the area that doesn't see as many storms is actually out there in the Atlantic. So you have sinking air over the Atlantic and air that's rising just off the west coast of Mexico. So that area of thunderstorms then, influences how the jet stream travels. When we go into La Nina, it flips around. So you have sinking air west of Mexico and more favorable air that's rising out in the Atlantic Ocean. And that's all determined by where the water temperatures are warmer or cooler than average, because, again, it influences where we have developing thunderstorms out over the ocean. And that, in turn, influences where the jet stream travels. So going into an El Nino with thunderstorms off the west coast of Mexico, we tend to have more active southern part of the United States, because there's actually two branches of the jet stream. You have your polar jet, which, as the name would suggest, is farther north and favors, driving the temperatures. And then the southern branch of the jet stream is called the subtropical jet. So in an El Nino, you have a more active subtropical jet, which is why we tend to see more rain favoring the southern tier of the United States. When we go into La Nina, the polar jet maybe is a bit stronger, and that favors stronger high pressure systems over the western part of the country. And, our rainfall tends to drop off usually in those La Nina patterns. So, yes, you don't have to be a climate expert or a full-fledged meteorologist to really appreciate, the changes in the ocean temperatures have dramatic influences on where the jet stream travels. And it's thousands of miles from Kansas, but it definitely plays a key role in our weather that we see day in and day out.
Yeah, it is fascinating. At the recording of this current podcast, we're in the third full week of August, and the heat dome that's been waffling back and forth and mostly staying west this summer, fortunately, has settled right over Kansas, and the intensity of the heat is frankly something I don't remember experience. The day prior to recording this podcast, Lawrence had a heat index of 130, which I didn't think was possible. What is the nature of this high pressure right now that that makes it so different.
Yeah, it's just a really strong high pressure, and patterns tend to repeat. We saw this lengthy spell of 100s at the end of July and early August, and unfortunately, yes, the heat ridge is back over the central U.S. But the longer range here, which is pretty typical as we move into September, that heat ridge begins to weaken. Of course, our amount of daylight starts to go down, and as we start to make that seasonal transition, this upper level high naturally is going to continue to weaken, and it's going to be shifting back west of the continental divide. So kind of glancing out there through the month of September, we're expecting the heat ridge to set up west of Kansas once again, which could very well favor more storms coming off the Rockies down into the central plains. I can't guarantee that the month of September is going to be wetter than average for the entire region. Now, I think it could once again be a setup for more rains in western Kansas. Areas farther east we'll get some rain. I don't know that it'll be a blockbuster wet month of September, but the heat ridge is expected to go back west of us into September, and therefore we're not likely to see a period like this shape up once again. I know we're setting some record highs right now across the central part of the country. Other places had to deal with this earlier this summer. But again, what we're still feeling, I think, is some influence of the La Nina, but the rainfall pattern would suggest that we've seen a little bit of the onset of El Nino. So it's not a light switch kind of setup here. We got to wait for one to move out, the other one to take hold. And we're just at the beginning stages of the El Nino, but there's still a little bit of La Nina influence in what we're seeing right now. And I don't think that the length of triple digits, this major heat wave that's setting up or has been in place, is going to be, at the end of the day, anything for the record books in terms of duration. But it's not a lot of fun. I think we can all agree on that. And the sooner we can replace it with rains and some cooler weather, we'll all be grateful for that.
Absolutely, and did a nice job of recharging the soil moisture in the western third of the state. Are you worried about any kind of flash drought within the next 10 days to 2 weeks?
I don't see a flash drought developing at all. We just don't look to stay in a pattern that's going to be hot and dry enough, long enough, where we might see the drought expand again back into western Kansas. Even if we had an area or two that went from no drought back into D0, which would be considered abnormally dry, I think it's short-lived as we move on into fall. We do have to remember that, on average, September and traditionally October too don't tend to be real wet months for us anyway. As the humidity starts to go away and fall, our rainfall sometimes starts to follow suit. But I don't foresee any flash drought redeveloping. If anything, I think we're going to eventually continue to see more improvement in the drought through most of Kansas. I wish it were over with for everybody, but unfortunately these droughts, they just take a long time to work their way out of, and hopefully we'll have some better news down the road. But I still see a pattern developing here where we start to get more rain. And some of the long-range 30-day outlooks are suggesting that the first half of September looks cooler than average. That obviously would help us out. The second half of September looking to be near or slightly above on temperatures. And then rainfall as a whole for September looks like it will favor slightly above average for the western half of Kansas and closer to average central and east.
Well, that would be good news for wheat farmers. Having the opportunity to plant into some moisture would be a change. So, Ross, if you don't mind, let's do a little bit of a lightning round here and jump around on some topics. Since we're talking about crops, I think one of the more controversial discussions out there is our changing crop rotations changing the weather? I don't know how many. It's a crazy amount how many gallons of water an acre of corn will transpire or respire during a day. So the fact that we've moved our corn and soybeans more into western Kansas, does that have a micro effect on the weather at all?
It would be a little hard to measure that, I think. Certainly down near what we call the boundary layer or the surface, I think you would see that through evapotranspiration. Obviously the plants are giving off some of that humidity, and that would have a little bit of an effect that we as humans would feel. But in the overall climate sense and the overall weather pattern sense, I'm not sure that we're really seeing much of an influence on patterns because of our crop rotations and what we've done, moving soybeans and corn farther west. We just haven't seen any evidence of that. But I will say this summer has been somewhat interesting in the fact, and I think it goes solely to the fact that we've just had more rains in western Kansas, but the humidity, when we look at maps, seeing western Kansas have dew point temperatures that get above 60 in summertime is somewhat of a rare occurrence, and we've seen multiple instances of having much higher humidity in western Kansas, but I think that is contributed more to the fact that we've just been getting more rain. So if you've got above average precipitation, that subsoil moisture, when you're evaporating that from the ground, that is going to have an influence on your day-to-day humidity, but I don't think that's necessarily related to the change in the crops that we've seen advance farther west.
Is the desert truly more of an impact, dry line, the dry air that's coming into the high plains?
Yeah, that's something that we have to keep an eye on because we get these southwesterly winds, usually at about 5,000 feet off the ground, and that dry desert air, as it advances into the plains, that dry line, just as a reminder, is a separation between the very humid Gulf of Mexico air that gets pulled in across Texas, Oklahoma, and typically the central and eastern sections of Kansas, and then your dry desert air that comes in from Amarillo and out there in eastern Colorado. That colliding boundary, the dry line, does favor some pretty significant storms usually, but we don't really know exactly where each setup that we're dealing with respect to different rounds of weather. That dry line can either be farther east or it can be farther west. We haven't seen any research suggesting that dry line has positioned more permanently farther east or farther west. And I think a lot of that is just because we've been in such a weird state lately with this ongoing drought. We've had a 3-year La Nina. So, yes, the dry desert air coming in is a significant factor in helping determine where some of our more significant rounds of storms are going to be. But we just don't know where that new positioning is going to be.
2 years ago, on December 15th, I was driving through western Kansas and a little windstorm came up. I was in Hays when that windstorm hit. Of course, it made a lot of news across all the state with up to 90-mile-an-hour winds and posed some fire problems. My thoughts, Ross, when I was driving through the state is that, number one, this would have been a lot worse if it was the 30s because I could see the either rows of corn residue or green wheat fields, and knowing that the dust that was blowing was not as bad as it could have been. So kudos to the farmers for that. But we've set ourselves up for more of a fire weather situation, I think. So how anomalous was that windstorm that we had in December 2 years ago?
Yeah, that was December 15th. That was such an unusual day. And actually, we saw like 3 or 4 days in advance that it looked like it was going to be a pretty rough go of it. It was such an intense low pressure system, and how this works, 5,000 feet off the ground, we'll see sometimes winds of 70 or 80 miles per hour. When that wind happens in the middle of the afternoon, we tend to mix, or we bring that stronger wind 5,000 feet off the ground, we bring it down to the surface. And that's exactly what happened on that December afternoon. It's not uncommon at all to have stronger winds aloft at night. And because the sun is not out, we don't bring those winds down to the surface overnight. But in the daytime, when the sun is up and the atmosphere is mixing like one giant mixing bowl, we bring that stronger wind down to the surface, and that's what happened on that afternoon. We had winds that were gusting upwards of 90 to 100 miles per hour, and that ongoing drought, it's almost eerie because of what we've seen happen out in Hawaii. Same situation there. You get a spark, you've got some fuel there for it, and if the winds are even 40 to 50, that can lead to a pretty significant fire outbreak in a short amount of time. I think what concerns me a little bit in thinking about the next couple of years is that if we go through an El Nino and we do end up with better rainfall, we know what that's going to do to our pasture grasses. We're going to have more grass, more fuel, and in the coming years, we get a spark, we get a fire. Well, now all of a sudden we've got this blue stem that's really tall, thicker grass. You're going to have bigger fires. Well, we're just coming out of a drought when the grass maybe hasn't been quite as thick and tall. So your fuels are maybe a little less, and our fires this year weren't quite as bad as they have been in recent years. But that December storm was just really one for the books because it was so intense. I think the only thing that worked in our favor that day is the fact that it didn't stick around for very long. It was here maybe 8 to 12 hours, and then it was that night it was already up around Chicago. Had it stuck around like some intense low pressure systems can do, we'd have had tremendous wind for a couple of days. So we're really glad that thing hit and was gone in just a matter of 12 to 18 hours.
Personally, I experienced 90-mile-an-hour winds at my house, and I'd rather not do that again. Is that not an F1 tornado level wind, or
at 90? I believe that is still
F0.
At F0. I think that's still on the lower end. Now it would classify, if memory serves me correctly, as a Cat 1 hurricane, which is what we were looking at because the barometric pressure in that storm was comparable to a low end hurricane. Very, very intense low pressure system. Again, happened in the middle of the afternoon. Those stronger winds, 5,000 feet off the ground, get carried down to the surface. And it was just a really rough afternoon. But I believe my parents up in central Kansas measured 91 on the little weather station they have. But that was a really bad day. I think most of us won't soon forget. And those scenarios, fortunately, are pretty rare. Most of our windy scenarios that play out around here, usually you're talking about winds of 50 to 60, but getting something more than that takes a special kind of scenario.
Imagine the biggest pressure on you as a meteorologist is guiding firefighters as far as wind direction and speed, right? I mean, how challenging is that?
Most of the time we do a pretty good job with gauging wind direction. Our short-term models that update every hour have a really good, nice handle on shifts in the wind. So we're pretty good at detecting that. And I would say that's maybe one of the easier things that we have to predict day in and day out is figuring out wind direction. Wind speed can sometimes be a bit of a challenge, and I think it's mostly because, we as humans are not very good at estimating wind speeds. Even myself as a meteorologist, estimating wind speeds is a really hard thing to do. So it might actually be 10 to 20, and we might feel like it's stronger than that. But wind speed can sometimes be a little bit of a challenge because, again, when we think about the atmosphere and the lowest 5,000 feet above us, it's just, especially in the afternoon, it's one giant mixing bowl. And this is why we get occasional gusts of around, let's say 20 to 30, and then the wind goes down because the atmosphere is just one big mixing pot. So sometimes getting a really good handle on wind speed can be a bit of a challenge just because there's so much stuff happening in the lowest 5,000 feet of the atmosphere.
Well, you mentioned weather models. Let's change topics here a little bit. It's getting, frankly, a little scary how accurate some of these short-term weather models are in predicting thunderstorms and things like that. I had a discussion with a friend the other day. We were talking about AI, artificial intelligence, and my argument was that weather modeling is artificial intelligence that's been with us for decades because those models learn from conditions, recognize future conditions, and improve. Am I accurate in saying that? Would you say weather modeling is a form of AI?
Yeah, I would say that you could say that because, essentially what we're doing is we're measuring the day-to-day weather and we're inputting these initial conditions. The computer model then takes its known set of equations and it will calculate all of these different problems given the initial conditions. And then at the end, we get what we look at are maps and charts and trends. So there is a level of AI that one could draw from this description of how these models work. And there's so many different models out there, which is probably, for me, what is a little bit crazy sometimes, especially in the world of social media. Sometimes you can have a model that goes out 10 days and has the most bizarre output on it. And then it's almost like all of us are held to that particular model output, even though the meteorologists are not saying that's what's going to happen. If a particular model gets traction online, all of a sudden people start to assume that's the gospel, that's what's going to happen. So we have to have a little bit of a balance here in looking at all of this data, which is just increasing every single day. It's like drinking from a fire hose sometimes because models are updating. We've got a lot of satellite information. We've never before had this much ground measurements with the Mesonet that's out there, a lot of home weather stations, so much information coming at us to try to sort through what is good information, what maybe has errors in the data. I know for me, when I'm looking at this one model that goes out sometimes 15 and 30 days, it's almost always showing the whole country as warm. And it doesn't always work out that way. So this model, and again, it doesn't speak for all of them, has a very difficult time in highlighting areas that are going to be cooler than average. So I can recognize a model bias, and that's something that some meteorologists struggle with, is determining this model is good for this time of the year, this one not so much. What are the biases of these models? So yes, there is a level of AI that one could say has been involved with computer modeling, but because there's so many of them out there, sometimes I suppose that's what it's a little bit of job security, because we have to go through all of this stuff and figure out this information's no good. This is the model to use at this time of the year. And hopefully that's reflected then in some of the stuff that you see.
You mentioned the importance of sampling data either through Mesonet or weather balloons or aircraft. And I guess we have a dream here in the wheat world that eventually we're going to be able to release a wheat variety with its own prescription for production. It's going to have fertility data, disease resistance. You enter your soil type, and then you layer your weather data upon that, and you're going to be able to kind of package that production for that wheat variety. If your target is 50 bushels an acre, it's going to give you step-by-step process to do that. Does there need to be more sampling in different areas on a more frequent basis to get to that kind of level?
I definitely can see where that would be helpful. My concern is that, we get into these summer patterns, like a lot of farmers have been telling me. What's been so weird about the summer is just how spotty the rainfall has been. 2 miles down the road, Farmer John maybe got 5 inches of rain, and 2 miles away it was maybe a half of an inch. So the spotty nature is something I don't think that we're ever going to be able to completely work around. But I will say, for me, in the meteorology world, it really is helpful, the more rain gauges that are out there, to try to pin down, where did we end up getting more rain? Where was there less rain? Temperature data. I'm not going to ever say that more isn't, it's helpful. It really is to have more data, more sampling of ground observations. Because it does help the computer modeling world try to get a handle on what's going to be happening, not just in the next couple of days, but maybe 5, 6, even 7 days down the road. Higher resolution models maybe will help steer us in the direction that you're referring to there. But I don't know. I still think we have quite a ways to go yet before we really get there. But I think we are moving in the right direction by having more sampling data via the Mesonet. Again, home weather stations, a lot of people like to know what's happening in their immediate area, and I think it's good.
Yeah, we're doing the same thing from the agriculture side, more and more data, and I think someday those two will intersect, and amazing things might come out of that. So, well, Ross, what's more challenging for you, forecasting summertime weather or winter weather?
I would say winter weather is a bit more challenging, just because, first of all, there are so many more variables. In summertime, we don't have to worry about precipitation type. So we know it's going to be rain. It's just a matter of figuring out where it's going to be and looking at storms. Winter weather offers up a lot more challenges, because you've got to deal with dry air that can evaporate snowflakes. You've also got the precipitation type. Are you going to get more rain? Are you going to get more snow? When's the transition time? Then you're dealing with what are called banding effects, where you might end up with a heavy band of snow, and 2 or 3 miles outside of that, there may not be any snow at all. Your temperatures are crucial. The storm track is so important. So winter weather has so many more variables that we have to take into consideration. Summertime stuff, I think you could ask any meteorologist and they would tell you that snowfall is still by far one of the hardest things to predict. And then you can have a really good forecast that's gone out, and then people don't measure the same. Some people will stick a yardstick down in a ditch and tell you, oh, you were wrong. We got way more snow than you were saying we were going to get. But As much as I enjoy a good spring, summer thunderstorm, there's still that fascinating part of a winter storm and really applying the information that you have, the modeling, figuring out where the snow is going to be, what the precipitation type is going to be. It's not something that's clear and cut usually. So I enjoy the challenge of winter weather forecasting. But that being said, it does come with oftentimes some very interesting feedback that we get from customers.
Yeah, what I'm intrigued by snow is how important everything going up the cloud and different layers, how important just perfect those situations have to be for snow to fall. That's not easy to do in Kansas, is it?
Right. And then you got to figure out your snow to liquid ratio. We've had instances in the last couple of winters where our temperature down in single digits and teens, you need a lot more moisture to get more significant snowfall in those kinds of setups. So you've got to make sure that your temperature forecast is right. And then you can start talking about what the snow to water ratio is going to be. And that's offers up a lot of challenges for us as well. So winter weather is it's a beast, but I certainly enjoy the challenge of it. And I think all of us, in agriculture know the importance of a good snow. And if it can come down without 30-mile-per-hour winds, even better.
Yeah. Unlikely in Kansas, it seems.
Usually it is. That's right.
El Nino, warmer and wetter winter, does that necessarily mean less snow?
Not necessarily, because some of our biggest snows have come in El Nino setups. It does. I don't think we ever go into a winter season where we can say with high confidence that this is going to be a big snowy season. Now, yes, we can go into seasons and say high confidence that it's going to be wetter than average, but determining rain versus snow, again, sometimes we can be 2 days out and still not even know if we're going to have where that split's going to be. So El Nino winter, yes, initially it does look like we're going to probably have an above average setup for moisture this winter. It doesn't mean that we're necessarily going to have a whole bunch of snow this winter. We don't know. It looks like there's a pretty good chance of above average precipitation. And even though we're leaning toward it being milder than the last couple of winters have been, again, sometimes if you're right there on the threshold, warmer or milder temperatures might actually mean bigger snows if you're closer to freezing. So we'll just have to wait and see.
Well, Ross, it's been great visiting with you, and you more than others probably know the challenges farmers are experiencing. Any final words of optimism for wheat farmers in the state?
I feel for everybody in agriculture. We've been through some rough years lately, and wheat has, as they say, 9 lives, and maybe for some of you saw all 9 of them expire. But I feel like better days are coming. We know that the pattern that we've been in of drought and heat, it will come back. It seems like once every 10 years we have a pretty rough drought. But I think what is encouraging here moving through the next at least 18 months, perhaps 2 years, it looks a lot better than what we've seen lately. So stay the course, be patient, and it certainly looks like better days are ahead.
Appreciate it, Ross. Thanks for your time.
Appreciate it. Thank you.
Thank you to meteorologist Ross Jansen for joining us on this episode of the Wheats on Your Mind podcast. If you have a topic you'd like us to cover in the future or have a question for one of our guests, please email us at podcast@kswheat.com. I'm Aaron Harries. Thanks for listening.